everyone, and welcome back. So sorry if I sound weird. My voice has kind of been in and out all day, so sorry about that. So if I sound a little different, I'm a little under the weather today. So we're going to start with Unit 6.3 today. This is triangles, and this is found on page 503 in your textbook. All right, let's go ahead and make sure our names are at the top, class hour, and today's date. And let's see what we're going to learn for today. So our objectives for today, we're going to identify and classify triangles. Identify and classify triangles. And then we're going to find missing angle measures. Find missing angle measures. All right. All right, so the main thing to know for today is that the sum of the angles of a triangle equals 180 degrees. So we take the inside or the interior angles and we add up each of those. We will come up with 180 degrees. All right, so let's take a look at example 1. It says find the value of x in triangle PQR. All right, so we have 89 in angle R. We have 54 for angle Q. We're trying to find angle P, which is our x. So if we know that there's 180 degrees, then we are just going to subtract what we already have. I am going to solve this algebraically because that's how it usually is on the state test. So I realize you can just subtract, but we are going to write it out algebraically. All right, so we're going to start with x, and then I'm going to add those two together. So we're going to take 89 and 54, and let's add those together. 89 and 54, so that's going to be, let's see, 13, carry the 1, so that's 143 degrees. And that's all equal to 180 degrees. All right, so from there we're going to subtract 143. Okay, so 180 minus 143, and looks like we're going to get 37. Okay, and let's grab our calculators and let's check that real quick. So let's quickly take 37 plus 89 plus 54. And I came up with 180 degrees, so I know that I solved it correctly. All right, so for this one, x equals 37. The main thing to watch for is sometimes they're going to ask you for an angle measure, which in this case is actually the same as just finding x, and sometimes we only have to find x. So it just depends on what they're looking for, so be careful with that kind of stuff. All right, let's go ahead and move on to the next one then. All right, so for this one, we have to find the measure of angle E in triangle DEF if the measure of angle D is 62 and the measure of angle F is 39 degrees. So let's go ahead and pause it and try that one. All right, so let's take a look. So we've got 62 and 39, so when we add those together, that's going to give us 101. So that's going to be x plus 101 equals 180. I'm going to subtract off 101 on both sides. Subtract that, and that's going to, of course, give us 79 degrees. Okay, and then double check it. So when I take 79 plus 62 plus 39, and we come up with 180 degrees. So that is correct. All right, so in this case, it would be 79. All right, let's take a look at the measures of, example number 2, sorry. It says the measures of the angles of triangle ABC are in the ratio of 1 to 3 to 8. What are the measures of the angles? All right, that's why I told you on the first one to solve algebraically, because now we have nothing except for ratios. All right, so what we're going to do is we're just going to draw a quick triangle. This is in no way how it's supposed to look. I'm just drawing something so that way I've got something to look at. All right, well, what you do is you're just going to pick angles, and where there's a 1, then we're going to put an x. So we're going to do 1x, which is just x, 3, so that's actually going to be 3x, and then 8, of course, would be 8x. And again, my picture is in no way close to how it's supposed to look. I'm just drawing something quick. All right, so again, we come back to the interior sum, which is 180 degrees, which means if we add up all of these angles together, so x, 3x, and 8x, we're going to come up with 180 degrees. So let's add those up. So x by itself, of course, means 1x, and then we're going to add it to 3x, so 1 plus 3 would make 4x, and then I have 4x plus 8x, and that's going to leave us with 12x. So we add all the angles together, I get 12x, and again our rule tells us that when we add them together we come up with 180 degrees. Alright, so we're going to have 12x equals 180. We're going to divide by 12, and let's type that in just so we know we're right. So 180, divided by 12, and it came up to 15. Alright, now this is what I was talking about a while ago. What does the question specifically ask? It says, what are the measures of the angles? Okay, so it's not what x equals, it's what the angles measure. So what does the first angle equal? Well, x by itself is 15, so one of them is 15 degrees. And then we need 3 times the x amount, so 3 times 15 would be 45 degrees. And then we have 8 times 15, so 8 times 15 then would give us 120 degrees. Alright, so sometimes x is not always the answer. In this case, it was part of the answer, but it wasn't all of the answer. Alright, so make sure you go through each time, read very carefully. Sometimes you're just finding x, sometimes you're not. Alright, and that's one of the hardest things with geometry is you have to get in the habit of not just find x and move on. You got to really read through and see if this is what you're really supposed to be getting. Alright, so let's go ahead and continue on. Okay, this time it says the measures of the angles of triangles of a triangle are in the ratio of 1 to 3 to 6. So what are the measures of the angles? Okay, so let's go ahead and pause this and let's try this one. And let's go ahead and take a look. So again, I'm just going to draw a quick triangle. Again, it has no significance whatsoever. So x by itself, 3 means 3x. In this case, this one will be 6x. All right, so again, when I add all those together, we have x, which is 1, 3, which would be 4, and then 4 plus 6 would be 10x. So I have 10x equals 180. Okay, we're going to divide that by 10. That makes easy math, so that makes 18. All right, and again, we're finding what are the measures of each angle. So x would be 18. We're going to do 3 times 18. So let's do that. 3 times 18. That was 54. Oops, forgot my degrees there. Sorry about that. And then we have 6. So we 6 times 18, and that, of course, makes 108. So 108 degrees. All right, so again, when you do these ratio ones, you're just putting an x behind them, add them all together, and then put it equal to 180, and it's that simple. All right, nothing too crazy on that one. All right, let's go ahead and turn the page, and let's look at the next part. All right, for example 3, it says, find the measure of angle 2 formed by the legs of the director's chair when the measure of angle 5 is 168 degrees. Okay, so in this case right here, we know that this part is 168. Well, we're supposed to find what the measure of angle 2 is, which is right here on the other side. Okay, so if I know that this one is here and this one's here, then we need to figure out what those are. Well, if you can recall back from lesson 6.2, we talked about supplementary angles. We learned that supplementary angles are 2 angles that have a sum of 180 degrees. All right. So again, if I kind of take out that little part right here, so let me get some white, so I can kind of white that out. Oops. Sorry about that. Let's try that again. There we go. Okay, so if I kind of white it out this part right here, okay, do you see how now we have a completely straight line when we add those together? All right, so that's what we're looking at for that part. Okay, so again, that's hard for some people in geometry to visualize that there's 2 things that are actually making up a 3rd thing. All right, so in this case, we're going to have the unknown, which is angle 2. So the measure of angle 2 is unknown, so that's our x. Oh, I'm still writing in white. That'd be good. There we go. Let's write in black so we can see what we're doing. Okay, so then we'll have x plus, and then we're going to have 168 degrees. And that's going to make a straight line, which of course is 180 degrees. So again, this is basically just a review then of supplementary angles so far. Okay, so we're going to subtract off 168. All right, that's going to give us x equals, and then let's find the difference here. So 180 minus 168, that's going to give us 12. Okay, so the measure of angle 2 is 12. So let's write that out. So the measure of angle 2 equals 12 degrees. Let's kind of circle that there. Okay. Now, another way to do this is, if you can't view it as supplementary angles, there is, it's actually called a theorem, but really a theorem is just the rule. There's a rule that says that the exterior angle plus the interior angle of a triangle always add up to 180 degrees, because of course it'll always make a straight line just like it did on that one. All right. So,
I don't really like these arbitrary categories.
Sorry, my Siri kicked on. Sorry about that. Put him way over there. I have no idea what he was doing. Sometimes he asks questions and he thinks I'm asking him questions, so sorry about that. Anyway, so let's try this one for number 3. We're going to use the same example. This time it says, suppose the measure of angle 4 is 102. So then what's the measure of angle 1? All right, so if this one here is 102, then what's this one right here? Okay, what are we trying to find with angle 1 right there? All right, so let's take a few seconds to work on that one. All right, so let's take a look. So if I have 180, and so that'll be x plus, and then I already have 102. We're going to subtract that then from 180. Again, I'm showing you algebraically. Oops, sorry. It should be 102 there. I'm showing you algebraically because on the state test, usually it's not that simple, and you're going to have to add a couple things all together. All right, they just made it easy math for us since we're just learning. So that's going to be x here equals, and then of course 180 minus 102 is going to give us 78. Okay, so the measure of angle 1 equals 78. In this case, it's degrees. Okay. I still have a lot of kids ask, like, how do I know if I'm supposed to label or not? The rule is if there's already an angle or a degree sign there in the angle, then you don't need to label again. All right, because it's kind of like double labeling, which is kind of weird to think of it that way, but that's really what's happening. So in this case, it just says 4. We need to specifically say degrees. Okay. Okay, let's do a little concept summary here. This is from previous years in geometry class. So let's take a look at our little chart here. Okay, so we have 3 kinds of triangles. We name them by their angles and by their sides. And there's 3 of each kind. All right, so for this one, if we classify it by its angles, the first type is the acute triangle, and an acute triangle is when they're all acute angles inside. So everything is less than 90 degrees. Okay, that's probably the most common ones that we have in math class, but not always. All right, next is obtuse. That means that there's 1 obtuse angle. And why is there only 1? Because, of course, if I have 2 obtuse angles, so if I just do 100 and 100, that's going to be over 180 degrees, right? We can only have up to 180 degrees. So there's no way to have 2 obtuse angles for a triangle. And then, of course, the easiest one to always recognize is the right triangle because of the little red box. So that indicates that there is 1 right angle. Again, there can't be 2 because 90 and 90 would already make 180, so there would be nothing left for the third angle. All right, so once we classify it by its angles, we can also classify it by its sides. All right, a triangle is scalene when all of the sides are different, meaning there are no congruent sides. And congruent, again, means equal or the same, okay, or same measure. Okay, isosceles means that there are at least 2 congruent sides. And just as a little side note here, these angles are actually congruent to each other down here. So if that's 43, then that one's going to be 43 as well. Okay, so 2 of the sides are the same, and then the 2 angles that are on bottom will also be the same, or on top, however it's flipped. But the 2 sides that match those bottom parts of the angles will always be the same as well. And then finally, we also have equilateral triangle. An equilateral triangle is when all the sides are the same, which means all of the angles are also the same. So if I have 180 degrees and they're all exactly the same, we take 180, divide that by 3. So what does each one measure? 60 degrees. So all angles are 60 degrees. Okay? And we actually call this also equiangular. Lateral, the word lateral means side, so equal sides. And there's also one called equiangular. I'll spell that out for you. Equiangular. Okay, so we know that the prefix equa means same, and then angular means of angles. So all the angles are the same. All right, so that one also has a special name. All right, so again, we can classify an angle, or a triangle, sorry, by 2 ways, by its angles and by its sides. All right, so as we go through these, we're going to use each one. Okay, let's do the first 2 all together. Example 4 says, classify each triangle by its angles and by its sides. All right, so in this case, we see the little pink box there. So that means that it's a right triangle, so it is right. And then we're also going to classify it by its sides. So do we have any matching angles? Nope, not in this case. That means every side is also different. So that would be right scalene. All right. As you move forward in math and you get into higher geometry, you'll learn to appreciate right triangles because they're special ones. And once you learn those, they all have special properties, and it makes the math a whole lot easier. All right. So there's several chapters on just right triangles whenever you get into upper geometry in high school. Okay, let's take a look at letter B. All right, so in this case, we have two of the tick marks, as they're called. So that means that two of the angles are congruent. We can see that. We have a 68 and a 68. So since two are exactly the same, that means that we have, let's see, we gotta do by angles first. So everything is less than 90, so it would be acute. And since everything is less than 90 degrees, that's going to make it, or two of the sides are the same, sorry, the angles make it acute. And then by the side, since there's two the same, that's going to make it isosceles. All right, so we have acute, isosceles. All right, let's go ahead and pause it and try numbers 4A and 4B down there on the Got It questions all by ourselves, and come back to me when you're ready. All right, let's go ahead and take a look. So we have no angles the same, so that means they are all less than 90 degrees, so it's going to make it acute. And since none of the sides are the same, that's going to be scalene. So this is acute. Ooh, yeah, that's right. Acute scalene. All right, 4B, everything is exactly the same, so that means it's going to be acute because they're all less than 90. And it's also equilateral. Right. Again, that's actually a special one because everything is exactly the same. We could also call this equiangular and equilateral too. All right, so either one will work for that one. All right, and that's it for this lesson. So take your time. Just remember when you're classifying, you need it by sides and by angles. All right, and then make sure that you remember that the angles inside will always add up to 180. And if you do have one on the outside, you just take 180 minus the part that you do have, and that will tell you the other part. All right, so thanks so much for watching. Again, sorry my voice is going out. It's just one of those things. So thanks for listening, and I'll see you next time. Bye.